Hello children, we are doing class 11 physics chapter 4 motion in a plane. Extra question 1. Question number 1. An aeroplane is flying horizontally at a height of 490 meter with a velocity of 360 km per hour. A bag containing ration is to be dropped to the Jawans on the ground. How far from them should the bag be released so that it directly falls over them? So an aeroplane is flying horizontally at a height of the aeroplane from the ground was 490 meter. Height of the aeroplane from the ground was 490 meter. The ground was 490 meter. And it was moving with a velocity. With how much velocity it was moving? Moving with a velocity of 360 km per hour. So it was moving with a velocity ux equal to 360 km per hour. A bag containing ration is to be dropped to the Jawans on the ground. So we are assuming that when the bag was dropped from the point A, then only with that same velocity the bag will move in the forward direction slightly. After some time it will follow a curved path because of gravity and finally falls near to the Jawans. We are assuming that Jawans were at the point B. Assuming that Jawans were at the point B. So with how much velocity that aeroplane was moving in the forward direction, with that same velocity, that bag will also move in the forward direction slightly. After that only it will follow a curved path. So this bag is having the horizontal motion as well as vertical motion. So first we are considering the horizontal motion. In the horizontal motion, we'll take what was the initial velocity along the x-axis. Initial velocity along x-axis was ux equal to 36 km per hour. We'll change into meter per second. Sorry, 360 km per hour. 1 km per hour is, and one more thing, by how much distance you should know. This distance along the horizontal will take as x and distance along the vertical height of that aeroplane as y. Also will take. Now for changing kilometer per hour, 1 km per hour equal to 5 by 18 meter per second. How we are getting means 1 kilometer is 1000 meter. 1 hour is 3600 seconds. So 1000 by 3600 when we will divide, we will get 5 by 18 meter per second. Now here we will write that as ux equal to 360 into 5 by 18 meter per second. 18 into 2 is 36. So 20 into 5. 18 into 2 is 36. When we will cancel, 20 into 5 equal to 100 meter per second. That is the motion along the initial velocity along the horizontal, that is ux. Now what is the acceleration along the horizontal? Acceleration along the horizontal. So when an object is moving in the horizontal direction, speed will be more dominating when compared to the acceleration due to gravity. So it has a tendency to move in the forward direction. So acceleration along the horizontal, or along horizontal motion we wrote. So acceleration ax will be equal to 0 because it was moving horizontally. Now displacement along the horizontal or distance covered. Displacement s or distance s equal to, along the horizontal it is sx actually. We'll take that one as horizontal distance as x. Now we'll apply the formula s equal to ut plus half at squared. Time taken, we don't know the time taken. Time equal to t. Now we'll apply the formula SC equal to ut plus half at squared. That S will take us Sx equal to ux into t plus half ax into t squared, half ax, a suffix x into t squared. Sx will take us x equal to ux, we got 100 meter per second plus half ax is 0 because the motion was along the horizontal. So that means here acceleration means acceleration due to gravity is actually 0. So 0 t squared. So you got the x as ut, no, ut, 100t plus. So x will be equal to 100t, equation number 1. Now we are considering the motion along vertical. Motion along vertical. Since we wrote motion along vertical in one case, I'll write here also motion along horizontal instead of motion along vertical. Horizontal motion, right? Motion along horizontal. Motion along horizontal. So now motion along the vertical. Initial velocity along vertical. Since the bag was not moving vertically upward at first, only horizontal motion was there. So initial velocity along the vertical uy will be equal to 0 because there was no up and down motion. So 0 meter per second. Now this bag followed a curved path in the downward direction. So acceleration in the downward direction is the acceleration due to gravity. Acceleration Ay equal to the acceleration due to gravity g, which is equal to plus g since it is in the downward direction plus g. That is equal to plus 9.8 meter per second squared. When an object moves towards the earth, acceleration will be equal to acceleration due to gravity. Now displacement or the distance covered along the vertical, distance or displacement also you can write Sy equal to same y only, but y we took as 490 meter. They gave not, we are not taken, they gave us 490 meter. Now how far from them should the bag be released? So later, that one was the x actually. X you have to find out. Now here time taken will be same in both the cases. Time equal to t. We'll apply the formula S equal to ut plus half at squared. So in the place of S we'll write Sy equal to uyt plus half ayt squared. So what is Sy? That is y only. Equal to uyt. Uyt, if you want to substitute, you can write or directly. So in the place of Sy or y, 490 equal to uy is 0, t plus half ay is either gt squared or 9.8, half into 9.8 t squared. So 490 equal to half and 9.8, 0 t will be 0 only. 2 and 9.8 when we'll cancel, we'll get 4.9 t squared. So what will be t squared now? Or 4.9 t squared equal to 490. So what will be t squared now? 490 divided by 4.9. 490 divided by 4.9. Multiply numerator and denominator with 10 for removing the decimal point. So it will be 4900 divided by 49. So you'll get t squared equal to, we multiply numerator and denominator with 10 for removing the decimal point. It will become 490 into 10, that is 4900, divided by 4.9 into 10, 49. So you'll get the answer 100. So t squared will be 100. If t squared is 100, what will be t? t equal to square root of 100. Square root of 100, you know, either you do prime factorization or 10 into 10 equal to 10 seconds. That was the time taken. But we want to find out how far from them should the bag be released. Means you want to find out the distance x. So here, substitute t equal to 10 in equation number 1. So you'll get x equal to 100t. That is equal to 100 into 10 equal to 1000 meter. So how far from them should the bag be released? So the bag should be released from them at a distance of how much? 1000 meter. So here the distance from which the bag should be released so that it directly falls over them. I just draw distance from which the bag should be released so that it directly falls over them. That is x equal to 1000 meter. So that means they should be, the distance between the bag and the jawan should be actually the horizontal distance x equal to 1000 meter.